Today we will discuss automata, language, alphabet and string. Automata. Actually, automata is a plural of automaton, which means something that works automatically. Before proceeding to the next topic, first we will talk about the machine. So anything that takes some input and produces output is called machine. And the input of the machine is called the language of the machine. Now we will discuss the main topic, that is the language. So by definition, language is a structured system of communication. But in our course, we will say that language is the input of the machine. Language is categorized into two main categories. That is the language used by machines and the language used by human beings. That is English, Urdu, French and so on. Certain attributes are common among all the languages. That is the alphabet, like ABC, Alif, Be, and so on. A string, in common language we will call it the word. Expressions, those are known as statements or sentence in human languages. Similarly, functions, you can say program or the paragraph in human language. Alphabet. By definition, a finite non-empty set of symbols, letters, is called an alphabet, and it is denoted by Greek letter sigma. For example, sigma AB, sigma 01. This is very important because usually we use the machine language, which is composed of zeros and ones. Similarly, we have so many other types of languages, like here we are taking IJK. Strings. By definition, concatenation of finite symbols from the alphabet is called a string. For example, let's say we have sigma AB. Then the strings are the combination of letters from sigma, that is A, AB, AB, triple A, double B, and so on. So these words or strings are actually the combination of the letters taken from the sigma. Empty string or null string. Actually, this is a string that contains no letters. Now let's say if we have sigma x, then the language we are defining here L1, where L1 is equal to x power n, and the values of n are 1, 2 and 3. Let's generate the language. So first of all, we will replace the each power of x by its corresponding values. That is, first of all, n is equal to 1, then n is equal to 2 and n is equal to 3. So x power 1 is equal to x, similarly x power 2 is equal to 2x or xx, and similarly x power 3 is equal to x, x and x. This way we have generated the language L1, which contains 1x, 2x and 3x. So here we have the three strings of the language L1. Let's take another example. The sigma is same, that is the same alphabet is used here. Now language is different. L2 x power n, n is equal to 1, 2, 3 and so on. In the previous example, we have n is equal to 1, 2 and 3, that is the finite number of strings were generated, while here we have infinite strings. Now we will replace n by the corresponding values. X power 1 is equal to x, x power 2 is equal to xx, similarly x power 3 is equal to 3 times x and so on. Now this language, that is the L2, will generate infinite strings, starting from the single x, the 2 times x, the 3 times x, the 4 times x and so on. Here is another example with the same alphabet, that is x. L3. L3 is equal to x power 2n. Now n is 2 times in each step. Now again we will replace n by the corresponding values. So x power 1, when it is multiplied by 2, so it becomes 2 times the x. Then the 4 times the x, the 6 times the x and the 8 times the x. This is also infinite language because it contains infinite strings. What are words? Words are strings belonging to some language. Let's say we have talked in the previous example, if sigma is equal to x, so x power n, 1, 2, 3 and so on. So we will have different strings, x, 2 times x and 3 times x, and we can call them the words of the language. An important thing to note here that all words are strings, but all strings are not words. Let's say if you consider the example of English language. So ABC could be an string, but ABC is not a word of the language English. Length of a string. It is represented by the pipe sign and it means the number of letters contained by a string. Let's say we take an example. Sigma is equal to AB. So we have a string AB, AB, A. The number of letters it contains are 5. So we may say that the length of a string S is equal to 5. Let's take another example. Here we have sigma B, then AX, then BY and the D. Now keep in mind that AX are not two letters, rather it's a single letter. Similarly, BY are not two letters but a single letter. So we may call B, X, by and the D. So we have four letters over here. Let's take string S. S contains B, A, X, B, Y, D. So if we tokenize them, so we will have B, this is the first letter, then AX, the second letter, the BY, the third letter, and D, the fourth letter. So it means the length of a string S is equal to 4. Now what is the reverse of a string? The reverse of a string is denoted by REV or S power R, and it is obtained by writing the letters of S in reverse order. Let's say if S is equal to ABC defined over language ABC, then reverse of a S or S power R is CBA, that is writing the letters in opposite order. Now consider another example. Let's say we have sigma B, X, by and D. Now we have a string S is equal to B, X, by and D. So if we are going to take the reverse of this string S, so what will we do? First we will write D, then we will write BY, then AX and B. So that becomes D, BY, AX and B. This is called the reverse of this.